Hey guys, so today we'll solve the SPOJ problem with problem ID 11. The name of the problem is factorial. Let's read the problem. So in this problem, the initial three paragraphs, you can read them if you want, but they are not at all related to the problem. So I'll start reading from where it's actually relevant. So I'll start reading from here. For example, they define the function z. For any positive integer n, z of n is the number of zeros at the end of the decimal form of number and factorial. So basically, the question is talking about a function z of n, so which gives us the number of trailing zeros at the end of n factorial. So they notice that this function never decreases. So if we have two numbers n1 less than n2, then z of n1 is less than equal to z of n2. It is because we can never lose any trailing zeros by multiplying by any positive integers. We can only get new and new zeros. The function z is very interesting, so we need a computer program that can determine its value efficiently. So the input of this problem is there is a single positive integer t on the first line of input, and it stands for the number of numbers to follow. So basically, the number of test cases is the first input, and then there are t lines with which consist of the number of which factorial we have to calculate and the number of trailing zeros we want. So for every output is for every number n, output a single line containing the single non-negative integer z of n. Okay, so let's just look at these inputs. So 6 is the number of test cases. So 3 factorial is 6. So there are no trailing zeros. So our output is zeros. Now, I don't know what 60 factorial is, but there must be 14 zeros at the end of 60 factorial. So let's solve this problem. So I'll tell you the logic behind this problem as I write the code. Fine. So firstly, we need to input the number of test cases. So t equal to int input. And for each test case, we'll run a for loop. So let our input number be equal to, let us call it num. So num equal to int input. Now there is one logic behind the trailing zeros, that the number of fives you have in the factorization of a particular number is the number of trailing zeros, right? So because like if you have a 5 factorial, let us suppose 5 factorial has 1 5, and 2 will always be there in a number. So number of 2's in the factorial will always be greater than number of 5's in the factorial. So you can actually just write one or two examples on paper and it would be very relevant. So let's just introduce the variable called p equal to 5. So I'll just comment something that number of fives determine the number of zeros, number of trailing zeros in the factorial. Okay, so let's have a variable add equal to num divided by p. So the method to calculate number of fives in the factorial is actually to divide the number by 5 and take the floor of that function, then divide the number by 25, then divide the number by 125, and as long as it goes. So number of zeros is equals to floor of n by 5 plus floor of n by 25 plus floor of n by 125 and so on. So let's call the number of zeros in our number as zeros. So zeros is equal to 0 initially. Now, while add greater than 0, zeros equal to zeros plus add. So basically, if add is the number of fives in the number, so like if add is a number of fives, so number of fives equals to number of zeros in the answer. Zeros equal to zeros plus add. After that, p equal to p into 5. Now we'll actually divide the number again by 5. So what this would happen is that the next time, so now p is equal to 25. So now when you will divide number by p, it would automatically divide it by 25, and then 125 the next time, and so on. So add equal to num divided by p. So that's it, and in the end we'll have to print zeros. Let's run the code. So Manan KG is my username, and yes, our answer is accepted. So that was all for this problem, and thank you guys.